Okay, so for the first part of 7.1, you should view the other video. This one is just talking about how you can use these rules of inference to construct a proof. And just to remember, we're just seeing a very small snippet of what you can do. If you look in the inside cover of the book, you'll see there's actually 8 rules of implication or inference, and when you're done, you actually have 18 rules. These are called rules of replacement, but you can also use them the same way. And we're actually, just to give you some little bit of introduction to this, you're just seeing those first 4. So remember, a lot of what we're doing in chapters 4, 5, 6, and 7 is looking at methods for determining whether or not a symbolic argument or a categorical argument is valid or invalid. And in chapter 6, you learn how to test propositional arguments for validity. Remember, you constructed a truth table, and then you tried to find a row where you had all true premises and a false conclusion. If you didn't have that, it was valid. If you did have it, it was invalid. So in chapter 7, when you're using these rules of replacement, you're going to learn a method in 7.1 where you would construct a proof using those rules of implication, and you'll use multiple rules to get from the premises to the conclusion. And when you do that, you're showing that an argument is valid. Now, this is a very sophisticated method of showing that an argument, propositional argument, is valid. The only limitation of it is it can't necessarily show you if it's invalid, because if you can't finish the proof, it could be invalid, but it could just be ingenuity, or you just haven't found the right rules. Now, anything you have will be valid, and your job will just be to construct a proof to show that it is valid, okay? Now, how do you do that? Well, you're going to use those first 4 rules that I gave you, or that you have in section 7.1, modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. And before you do it, you should look in the book where Hurley shows you invalid instances of those, trying to substitute for those rules. And he also gives you strategies for how to do that, how to construct a proof. So I have my rules here, or you could look on the inside cover or somewhere in the chapter. So you might want to pause the video as I'm doing it and look at your rules and just to see. So what Hurley tells you is, let's take a look at this first propositional argument. So these are the premises of the argument, and this is the conclusion. And you want to construct enough lines that allow you to use those rules to manipulate these premises in such a way that you can conclude validly with T by using those rules, okay? So the first thing to do is to look at what your conclusion is, and then to try to find that conclusion in your premises. And you see you have that conclusion here in the conditional of this disjunction. So in order to get to it, you're going to have to break down this disjunction and get this consequent out. And then you can try to, the disjunct out, and then you can try to break down this conditional to get to T, okay? So you know the only rule you have to break down this premise is disjunction. And since you have F on the left and you have not F on line 2, you can use disjunction to get D horseshoe T out. Now remember, you can't just go in and take out T, because when you have a disjunction, it allows you to pull out that entire consequent. And in this case, the consequent is equal to D horseshoe T, okay? So make sure that you pause that and make sure you understand that. These rules only work with the main operator. So for example, you might see that if you had this out, you would have the setup for modus ponens and you could get T out. But because this conditional is in the is inside of a, as part of a disjunction, you have to break down that main operator first. So that's why I'm doing disjunctive syllogism first. So using disjunctive syllogism, we have 1 and 2. will give us D, 1 and 2 will give us D horseshoe T by disjunctive syllogism. Okay, this would be my P, this is Q, and line 2, it would give me not P, therefore I can pull out whatever Q is, which we said in this case is D horseshoe T. Now, remember the ultimate goal is to get T out on a line by itself, that's what we would say. And we have right now the setup for modus ponens. We have D horseshoe T and we have D. So by modus ponens on lines 3 and 4, we can isolate T and get on a line by itself. Once you have that conclusion on a line by itself, you're done.